All right, guys, now I'm going to solve the second problem. It's actually the same problem with production. So here's the problem. Okay, guys, so here is the same question with production function. Consider an economy with two goods, again, X and Y, a firm and two consumers, Ali and Bob. Again, Px and Py are the prices for these two goods. Ali's utility function is the same, the Cobb-Douglas form, and his initial endowment is again 0, 4. Bob's utility function has this natural logarithm form, and his initial endowment is 2, 0. The firm, however, produces good X by using good Y as the input. The production function, f of Y, is square root of Y. Bob owns the firm and use pi to denote the firm's profit. All right, so that's it. All right, so I summarized again the problem here, agent A's utility function and endowment, agent B's utility function and endowment. And now I have the firm. So this is the technology of the firm. Firm is going to consume good Y because it's the input, and then produce good X. So this is how I'm going to write it. So the firm is supplier for good X and consumer, quote unquote, for good Y, because good Y is going to be consumed, it's an input, and then it's going to be plugged into the production function and spills out or sort of produce good X. Well, because, however, as in the case of agent A and B, X and Y for agent A and B can be different things, and same for firms. Or the firm is going to consume a different amount of Y and produce, different amount of X. All right, so therefore, I just want to put F on top of the X and Y there, just to indicate that these X and Y's belong to the firm. Well, you may say, Bob owns the firm, so isn't this X is the same as the Bob's X? No, Bob consumes X, all right, but with some, and consumes Y, some Y, and he does not, think it this way, the firm is a separate entity, individual, all right, but the thing is, the profit it will generate is going to be given to Bob. So the Bob actually is going to use the money generated by the firm. Okay, think it this way. The other thing is, remember, none of the agents, consumers or the producer owns money. The consumers can sell their endowments and then generate money, and with that money consume some X and Y. Firm, on the other hand, buys some inputs and then produce some output and then sell it in the market, and then with this money generated, pay back the amount of money he owned for the inputs, and then the remaining money, if there's any profit left, well, this profit will be given to Bob. He is the shareholder. Okay, so that's what happens. How do we solve this problem? Once again, we have to solve this problem in two parts. Part one, everybody should maximize, the consumers should maximize their utilities, firm should maximize its profit, and so we calculate the aggregate market demand and market supply. Then the second part is market clearance. The market should clear for each good. The supply must be equal to demand for good X and for good Y. Well, we already solved the utility maximization problem, if you remember. However, this time the utility maximization problem for Bob is going to be different because his budget constraint has changed. All right, so let's start the beginning, meaning let's start the utility function of agent A. Maximize utility by choosing X and Y subject to his budget constraint. Pxxa plus Pyya must be equal to the income he can generate by selling all his endowments, which is 0 times Px plus 4 times Py. There's no other income. Here, an important question you may ask. I mean, why are these guys selling all their endowments? Eventually, they're going to consume some X and Y, right? I mean, this guy, for example, he's going to consume some Y. Why not he sells only part of his Y? So this endowment, I'm sorry, this income is not going to be his real income. You see what I mean? It's like, don't confuse yourself. So think this approach as the follows. He, consumer A or B, he sells all the endowments he has and generates money. And then with this money, go back to the market and buys X and Y. All right? Here, there is no, I mean, in reality, there's a timing issue, right? I mean, when you sell your endowments, the price may change, and so you may not be able to buy them back, right? That's a problem. But there's no such thing here. The prices are fixed. Right? And then the second thing is like, who are you selling all these endowments? I mean, nobody is going to, I mean, if Bob is not going to buy those endowments, well, Agent A cannot generate all this income. You see what I mean? Well, this is a confusion, a very valid confusion. So again, think it this way. Assume that Agent A and B sells those endowments to market maker. All right? Market maker is someone outside of the market, has no interest in the market. He just basically governs the money transaction. All right? So this market maker is going to buy all the endowments from each agent, pay them money, and with that money, those agents are going to go back to this market maker and then pay this money and will buy, as many of good X and good Y they want. But the thing is, obviously, they cannot spend more money than they generated. All right? So think it this way. I hope that helps. All right. So this is the problem for Agent A. And this is the Agent B's problem. Maximize utility by choosing X. I mean, let's put B here as well. Let's put A here as well. Subject to his budget constraint, which is XPX, XBPX plus YBPY equals his income. So 2 times PX plus 0 times PY, so just 0. But remember, he owns the firm, and so pi is the profit that will be generated by the firm. So in this question, the budget constraint for Bob is different because of this pi, because pi can be positive, and in fact, it will be positive. All right? Well, what else? Later, I hope this place is going to be enough. And then the firm's decision, right? The maximize pi of F, the firm's profit, obviously by choosing XF and YF. So what is the profit function here? So be careful. So we maximize the following. So the profit is simple. The amount of good X that's going to be sold. So it's going to be PX. So the input prices and the output prices are the same thing in this economy. Don't forget that. All right. We don't have different input prices and different output prices. So the firm is going to produce X. So it's going to sell this XF at a price PX. So this is the revenue it will generate, right? It cannot sell good Y because good Y it's not producing good Y. So that's the revenue minus cost. So what is the cost? Well, cost is the amount of good Y it buys or consumes. So it's going to be PY times YF. All right, so this is the cost. It doesn't consume X. X is not an input. It consumes only Y and produces only X. So therefore, this is the revenue minus cost. Subject to, obviously, the technology, right? Square root of YF equal to XF. Clear? So writing this is important. And this is basically the only difference between this version of the question, I mean the production versus without production, which we solved in the previous episode video. So how do we solve this and each one of those? Again, marginal rate of substitution equal minus price ratio. The marginal rate of substitution here is just YA divided by XA minus equal minus PX over PY. So if you do the cross product, it's going to be XA PX equals YA PY. All right, we already had this. And plug this back to the budget constraint. We're going to have 2PXXA equals 4PY. So therefore, XA is going to be 2PY over PX. So this is his optimal demand. And then YA is going to be, so just plug it back here. You're going to multiply this and then PY, and then you're going to get 2. All right. So it's exactly the same as before. Well, what about Bob? Well, Bob's, again, marginal rate of substitution equals minus price ratio. Again, I'm doing this because the utility functions are nice and concave, or they have convex indifference curves. So the optimal solution is always in the interior, no boundary solution. Well, the marginal rate of substitution here, remember it was YB divided by XB equals minus PX over PY. I mean, it's 1 over XB divided by 1 over YB, but it boils down to this one. So therefore, XB PX equals YB PY. All right, same thing. The only difference is going to happen now when I plug it to the budget constraint. Well, because YB PY equals to this, so we're going to have 2PX XB equals 2PX plus pi. So divide both sides by 2PX. It means the optimal B consumption is going to be 1 plus pi divided by 2PX. So he would like to consume more good X. What about YB, however? YB is going to be this term times PX divided by PY. So it is PX over PY plus pi over 2PY. Okay, that's it. And then finally, how do we solve this problem? This is easier. We don't really need marginal rate of technical substitution. I mean, you can if you want to. I mean, I could do exactly the same thing here. Instead, I'm going to just plug this constraint into the profit function. So the profit function is going to become this. Remember, x of f is equal to square root of yf minus py yf. So how do I maximize this? Not partial, but it's total derivative with respect to yf, because this is a function of one variable only. Set it equal to 0. So when I take the derivative, I'm going to get 1 over 2 px yf to the power minus 1/2 minus py equals 0, right? So I send this guy to the other side. This is 1 over 2 px divided by square root of yf equals py, all right? So pull py here, so yf, and take the square of both sides. Yf is equal to px squared divided by 4py squared. Okay? That's it. Not that's it. Once I find the optimal output for good y, what is the optimal input? This is the optimal input. What is the optimal output, therefore? Just use this equality. Xf is going to be square root of this thing, which is px divided by 2py. All right? So that's it. That's the kind of first part. Now I'm going to do the second part of Walrasian equilibrium, which is market clearance. But first, I need to summarize, because I will use it, the market demand, total demand for good X. What is it? So who demands good X? Obviously Ali, Bob, and firm, Firm does not demand good X because good X is not an input. So therefore, the demand for good X is going to be Ali's demand and Bob's demand. That's it. Good. Demand for good Y. All right, who demands good Y? Ali. Oops, it's not X, it should be Y, right? YA plus Bob demands good Y, but the firm also demands good Y because Y, good Y is an input, so the firm will demand it. So YF. All right? Okay, well, what about the supply? I need these terms, so I don't need these terms, so let's get rid of them. Supply for good X. What is it? So who supplies good X? Obviously Ali and Bob by their endowments. The Ali's endowment for good X, is 0. Bob's endowment for good X is 2. What about firm? Does firm supply good X? Yes, remember good X is the output. So therefore XF. Well, what about the supply for good Y? Well, this time Ali supplies 4 units of good Y. Bob supplies 0 units of good Y. And the firm doesn't supply anything. It just consumes. So the input always consumed completely. Right? I mean, it shouldn't be wasteful because we maximize the input and the output. So the firm is not going to consume more input than he needs, and it is not going to produce more X than it can sell. So therefore, there's not going to be any supply for good Y. So that's it, 4. All right? All right, I summarized all the optimal demands for consumer A, B, and the firm, and optimal production for the firm. And these 2 conditions are the market clearance conditions. All right? So the demand for good X must be equal to the supply for good X, and the demand for good Y must be equal to the supply for good Y. So all I have to do to solve the Walrasian equilibrium is to plug all these into these 2 equations. All right, well, what does that mean? Well, XA plus XB is equal to, XA is 2PY over PX, plus XB is equal to 1 plus pi over 2PX, has to be equal to 2 plus XF, and XF is this, PX over 2PY. All right, so this is the market clearance condition for good X. All right, well, what is the market clearance condition for good Y? So the second equation, YA, which is 2, plus YB, which is PX over PY, plus pi over 2PY, plus the demand for input for the firm, it is PX square for PY square, has to be equal to the market supply, which is 4. So what I'm going to do is, we can calculate the profit by using the profit function of the firm, but instead of doing it, I am going to write both of these 2 equations as a function of pi, meaning I'm going to leave pi on the left-hand side and send everything else to the right-hand side. And then because, pi, the profit must be the same, I'm going to set them equal. And by doing this, I guarantee that both of the market clearing conditions for good X and good Y hold, actually. All right, so I don't need to check whether the market clearance condition for the other good holds once I solve this, for example. All right, so how can I pull pi here? Well, pi there is equal to, send 1 to the other side, 1 plus px over 2py minus 2py over px, right? Pi over 2px, obviously. So that means I'm going to multiply both sides by 2px to get rid of this. Pi has to be equal to 2px plus 2's will cancel out, px squared over py minus 4py. Okay, so this is the first equation coming from the market clearance condition for good x. And then from the second equation, pi over 2py equals 4 minus 2, so 2 minus px over py minus px squared over 4py squared, right? And then I'm going to get rid of this 2py by multiplying both sides by 2py. And as a result of this, pi, the profit is going to be 4py minus, py's will cancel out 2px. And then I'm going to have minus, py's will cancel out, px squared divided by 2py. Okay, so this is the second equation, which basically derived from the market clearance condition for good y. Well, pi is the same, so therefore this first term must be equal to the second term, all right? And so I'm going to skip this step, they're equal. So what I'm going to do, I'm going to clean things up, let's go slowly. 2px plus px squared over py minus 4py equals 4py minus 2px minus px squared over 2py. All right, and then now let's put all the terms on one side, and therefore we're going to leave the constant, probably it's going to be 0 on the other side. So where should I collect? Well, I should collect everything on the left hand side. So this is going to make 4px, right? And then minus 4 minus, there's going to be minus 4 minus 8py. And then I have px squared over py plus px squared over 2py, so I'm going to have plus 3px squared over 2py, which is equal to 0, because that's what we are left with. I'm going to get rid of 2py. How can I do that? Multiply both sides by 2py. So this is equivalent to the following, and let me rearrange. 3px squared minus 16po, I'm going to leave it to the end, plus 8, I have, all right, so let me write it this way. So once I multiply both sides by 2py, this is what I'm going to get, 3px squared plus 8px right? And then minus 16py squared equals 0 times 2py, which is just 0. All right, so what I have is this equation. 3px squared plus 8pxpy minus 16py squared. Well, what are the roots of these? Or can I write this as this? This is 4 minus 4, 4py, minus 4pi plus 4pi, multiplication of these two. This is 3px and 1. Just px, so both plus. So when I do the cross product, I'm going to have 12pxpy minus 4pxpy, so sum is going to be 8pxpy, yes. So therefore, this equation is nothing but 3px minus 4py times px plus 4py equals 0. All right? So this term, by the way, I'm looking for positive px and py. Zero price will never clear the market because these are increasing utility functions. If price of a good is 0, the consumers are going to demand this good infinite amount, and so supply is not infinite, hence the market will never clear. So the prices we're looking for in the Walrasian equilibrium are always positive, non-zero. Okay, so these are positive, this is positive, so this can never be 0, but this can be 0. So 3px minus 4py equals 0 means 3px equals 4py. I am looking for price ratio, so px over py must be equal to 4 over 3. That's it. So if you remember, when we didn't have production, the price ratio was px over p2, py I mean, it was 2. Now the price ratio is 4 over 3. What matters is it's less than 2. Does it make sense? Oh, yes, it does. Why? Well, because now there's a technology to produce more X. Remember, before the production in this problem, the price of good X is 2 times more than the price of good Y because the amount of good Y was 2 times more than good X. But now this ratio decreased. The reason is now they can produce some X by using Y. And so this additional production technology reduced down the price ratio. Okay? Well, the conclusion, the Walrasian equilibrium allocation and the price ratio or the price vector is the following. The allocation is basically, I'm going to plug px, py in all those, okay? I need to calculate pi. On top of my head, I can't remember what pi was. I think pi is px squared divided by 2 py. I'm not so sure. But the thing is, the Walrasian equilibrium is going to be xa, ya, this is for consumer A, and then xb, yb, and then x final and y final, firm, and then the price ratio, px, py. If you like, you can put star, which we know already this is 4 over 3, okay? And then you can also put stars here, but I already put A's and B's and F's on the as a superscript, so the star, I don't know where to put star. So here, as I said, in order to find the allocation, so this is the allocation, who gets what at the end of the trade. All I have to do is just to plug px-py ratio here. I'm supposed to find some real numbers here. And so this is the Walrasian equilibrium allocation and price vector. Okay? Hope that was clear.